Hello guys, my name is Alan and I tried to make a animation of a tank of water leaking and imploding. So I tried to use AI to create that scene. What's my prompt? Static camera, a large shared industrial metal tank standing right in a testing facility. The tank is cylindrical with a shiny metallic surface. Water is slowly drained from the bottom of the tank. On top of the tank there is a closed air valve. Then the tank's walls begin to visibly deform due to negative pressure. Finally the tank collapses inwards dramatically. The first AI used is an AI named Sora with that prompt, and here it is. You can see water explodes out of the tank, but then the tank's not imploding, so it's wrong. So then I changed my prompt a bit to focus more on the imploding part, and here it is. So you can see the AI made a big crack, but it doesn't look like it's from an implosion, and there's no water leaking out. I decided to use a different AI called Runway. Oh, there's a big object coming out of it, but the tank's not imploding, or is water coming out from a water valve, and that's not good. I changed the prompt again, and what? The water's coming out, but the tank's not imploding. So I decided to animate this model myself. So I used Blender to create because there's so much tools you can use. It can take months to master it. So I'm going to use Python coding to create it instead. To do that, I'm going to go to the top here and press scripting. And then I'm going to press new so I can get my code. So first, I'm going to type import bpy. It's going to import all the little items that we need. Next, we're going to create a define function. So we're going to type in create cylinder because this function is going to create our cylinder. Now we need our parameters, which is none, not none, name, the radius, the depth, location, orientation, and there are 3 zeros standing for no rotation on the x, the y, or the z-axis. Then there's going to be 16 vertices. And I made a mistake here, it's supposed to be a comma, not an L. So, why is there 16 vertices? It's because we're not going to create a perfect cylinder. The cylinder is going to be... The cylinder is going to have 16 vertices, which makes it look like a cylinder, but it's not actually a cylinder. So these are the parameters. So now we can start creating our... Oops, we forgot one. Material. It's just the material that we use. We're not gonna play around with that now, but we are going to later. So now we can start creating. So create a simplified cylindrical object. I'll add that comment here, bpy dot ups dot mesh dot primitive cylinder add. So the vertices of this cylinder is going to equal to the number of vertices we added here. The radius is equal to the radius we entered the parameters. The depth is equal to the depth we entered in the parameters. The location, that's also equal to the location we put in the parameters. Then we can close our parentheses. Next we're going to write obj equal to bpy.context.object. What that does, it just basically takes this and puts it in the obj, so you can now give it this name, which is the parameter we put up there. See, we are making sure we fill in every single part of this. And finally, the rotation yielder, which is equal to orientation, which we put up here. Now we're gonna put one of the last things. This is an if statement that says bj.data materials dot append material. Then we're gonna return the obj. This is we finished our first define function. Now we're going to go on to the second one. Let's skip a few lines and press the great def again. So this one is going to create the valves, but it's only create valve because we're going to use this function twice with barrier. And the first few parameters in this will be pretty much the same as the cylinder one. But there'll be a few changes which you'll see here. Look, there's a barrier location now instead of just one. That's because they're creating valve and barrier. The second change is we're going to add these parameters called frame start and frame end, which are the frames that this program, this animation is going to use to create our animation. Now we can add the common creative valve, which is a cylinder, and a rotating thin cylinder barrier cover. Now let's create the valve first. So the valve is equal to create cylinder, because you remember the valve is also a cylinder, so I can use our create cylinder function to create a valve. So create cylinder. Now I can enter the parameters up there. The name
which is going to equal F name valve. You can see we're taking the name we put in here and adding an underscore valve after that. And I'm going to close your quotations. And then radius is equal to 0.2 because it's not going to be that big. It's going to maybe a pretty small cylinder on top of this big collapsed cylinder and the cylinder in front of it, and coming out of it like this. And then the depth is equal to 1, so we're creating a large thin cylinder. Orientation, that's going to equal the valve orientation parameter we defined up here. And then for final one, location, though that's also going to equal our valve location parameter we put up there. So we've created our valve. Now we can create our barrier as a thin cylinder. So the barrier is equal to create cylinder, because we're also creating a cylinder. So the name, well, that's gotta be name barrier, which I explained how that works up here. Radius, it's a bit bigger than this radius up here, but it's still around the same depth. Well, it's not going to be that tall because it's a thin cylinder that's going to basically cover the valve. So its depth is way smaller than the valves. Orientation, that's going to be the barrier orientation. And finally for the location, that's barrier location. Okay, now for the final part of this function is to add animation to the barrier. Because for the animation is the barrier goes away, the water leaks out, and then the cylinder collapses. So to add the animation, we're going to first press barrier, keyframe, insert. So we're going to insert some keyframes for this barrier. Now we're going to write data path, rotation, Euler, frame, which is frame start, final rotation, which is equal to list, Oops. This one's supposed to be another line. So we're going to create another line. Then in here, go to barrier orientation. We're going to change the barrier orientation. And you'll see how in a second. So final rotation again, but instead we add 0 plus equals 1.75, which is rotate 90 degrees along x-axis. You see, and this is a comment, so I don't need the equal sign. Need this. So, why is it 90 degrees along the x-axis? Well, it's because I have to. Because here the circle is usually 360 degrees, but in here it's 2 pi. 1.57 is like 3/4 of pi, which is actually around 90 degrees, but yeah, 90 degrees. So that's our animation, barrier, rotation. You is equal to the tuple final rotation, and we're changing this to a tuple because you can see we first changed final rotation to a list. Now we change it back to a tuple because we can change a list, but we can't change a tuple. And since this was already a tuple, we changed it to a list, so I could do this. And then we changed it to a tuple, back to a tuple. So that's why we added that line. Okay, now we're gonna add the final frame, which is this. Buried a keyframe inside data path rotation equal frame equals frame end. Return valve and barrier. Okay, when this we're gonna have the longest defined function yet. Set up collapse simulation, but this time there's no parameters. And it just adds everything to the to the model. And it's just a set up collapse simulation. We're not adding the collapsing part yet. Right now, we're focusing on turning the barriers to make sure they work. We're gonna add them in future lessons. So, the comment set up the tank and collapse simulation. Tank create cylinder So our tank could also be a cylinder. So you see we're also using the create cylinder function. The name is collapsible tank. But we're going to collapse in the future, not today. Radius, it's going to be way bigger than the valves. Depth is equal to 5, also way bigger than the valve's location. So x is 0, z is 0. X is 0, y is 0, but z is not 0, it's 3. Because it's going to be slightly above the floor here. This little gray checkered floor. To make it easier to see. And then there's obviously gonna be 16 vertices. Okay, we've created the cylinder. Now time to add an air valve, because we're going to add an air valve and a water drain valve. So, which is pretty easy because we've had a define function earlier to create it for us. So, we're going to use that function. This name is going to be air valve. Its valve location is also going to be slightly above the gray checkered floor, comma, and the orientation, it's not going to be rotated anywhere, it's upright. So 0, 0, 0 is upright orientation. And next we're going to add the barrier location orientation. Now barrier is also going to be pretty high, but not as high as it could be higher than valve actually. And then last we're gonna add a barrier orientation, which is going to be also upright. And the frame start equals 95, but we're not going to use it this lesson. Frame start is at 100. So I've created the air valve. Now we can create our water drain valve, which we can copy and paste this and change a few things up. Okay, so instead of air valve, it's water valve. And we should change these names a bit. instead of air valve, we put water valve. Water barrier. Okay, name. Water valve location. It's not this, it's gonna be 0, -3, and a 0.7. So it's gonna be above this, it's gonna be in front of the cylinder, the big collapsible cylinder, and slightly above the floor. Then valve orientation is going to be 1.57, which, if you remember, is 90 degrees. That's Sutter's orientation. And then here, the barrier location is not this, it's going to be 0.7, -3.6, and 0. The orientation, we're just going to change this X value, which is 1.57, and the frame start is 30, and the frame end is 40. We're going to rotate the valve this lesson. Okay, we're done. This is the last defined function, which is setup scene. And here, there's no parameters. So, set up the scene. First, you have to add a floor. And dot primitive plane add. We'll set the size to 50. The location is just 0, 0, 0 for X, Y, and Z. And forgot to add the other parenthesis. Next line is bpy dot context dot object. It's the same thing we did with the cylinder define function. And they're also going to add the floor's name, which is floor. I'll create a collapsing tank. Set up collapse simulation. Okay, that's his define function. Now we can start the rest. We can use them to create our scene. So clear the scene first. We don't want the unwanted parts. Okay. Okay. The object dot delete use global is set to false, and set up the scene, which is just setup scene. Then we're gonna set the animation timeline so I can animate. Dot scene dot frame start is equal to 1. Frame, the ending frame is equal to 90. Then you may be wondering, the air valve. If you remember the air valve, we set the frames on frame end to 100. You may be wondering why the last frame is 90. Well, that's because the air valve won't have any animations. But since we need a frames on frame, we just put it higher than the max length of the air valve. So now you just have to check for any mistakes by running it. See, I have no typos or mistakes. And if you get a animation, you can look at your animation. You can see so far you only have the barrier turning, but later in the next lesson we have the collapsing tank. So that's it for this lesson. Bye.